Okay, good morning, everyone. It's Saturday, April 18th, 2020. And today we are going to enter Chapter 7, 7.1 in particular, entitled Completing the Square. All right, and our first objective, A, is to solve quadratics by taking the square root of both sides. All right, so what does it mean? Get my pen back here. Not cooperating here. All right, here's a basic example about taking the square root of both sides, and many of us have had this already. But when we're trying to get x isolated, meaning by itself, so far there's two of them here. So this is like x times x, which equals x squared. That equals 16. So when I take the square root of both sides, then I've got the square root of x squared. Well, what do we know? There's two of them here. For every two you take out one, if that index is 2. So this just becomes x by itself. And that will equal the square root of 16, which is plus or minus 4. And this is the part we have to remember to include, because remember my explanation several days ago that it was this can be negative 4 squared, which is going to be 16, or positive 4 squared. So if this were negative 4 squared, that'll give you 16, and just simply 4 squared also gives you 16. So you have two answers, so we're going to have to put plus or minus in front of our answer for the square rooting. Okay, so that's just a basic square rooting property, and this is the important part here that we have a tendency of overlooking. All right, but let's see if we can overcome that by making a couple mistakes on it, not being habitually wrong by making the same mistake. All right, let's go on to our first example. Yes. So example number 1 is this binomial squared, which is going to be a big feature of this section of the book where we're at. Okay, so looking at this, because this is squared, to separate that, I have to take the square root of that. So I'm going to take the square, what I do to one side, I have to do to the other. So I got the square root of both sides here. So my answer on the left is just going to be 2x minus 3. And that's going to equal the square root of 25. Well, that'll be plus or minus 5. So far. Okay, so now when I solve this, let's take a look at what we're going to do here. I'm going to add 3 to both sides. Let's add 3 to both sides. And I'm going to get 2x equals, well, let's see, I have 3 plus or minus 5. No, I brought a 2. 3. I'm going to write this up as 3 plus or minus 5 equals. All right, and now I'm going to get the x by itself, so I'm going to divide both sides by 2. And now I'm going to have that x equals 3 plus or minus 5 over 2. And then I suppose I could separate that. I could say 3 plus 5, which is 8, divided by 2 equals 4. All right, 3 plus 5, using the plus sign, 3 plus 5 is 8, divided by 2 is 4. Or I can go ahead and say 3 minus 5. 3 minus 5 is negative 2 divided by 2, which is negative 1. So I have 2 solutions for this answer. And of course, because I had an x squared to start, or something squared, this could become squared. before taking the root, that's telling me I have two answers. Now I could plug in and figure out if my answer is correct. All right, so let's see. If I'll take away the roots here. This was the original problem. So what have I got here? I've got 2 times 4. That was one of our answers. 2 times 4 minus 3 squared. Does that equal 25? 2 times 4 is 8. 8 minus 3 is 5. 5 squared, 25. So that checks. 4 checks. 4 checks. And the other number was -1. And let's see, if I put a -1 here, what does that equal? Well, 2 times -1 is -2. And -2 minus 3 is -5. And -5 squared is 25. So the -1 checks. So those two check, and that's our answers. Those are our answers for problem number 1. For example, number 1. Let's go on to example 2. So how about example 2? I'm going to have 3x minus 1 squared, and that's going to equal -12. And solve this for x. Okay, let's do it. Take the square root of both sides. Oh, now I've got the square root of a negative number, right? All right, so the left side just going to be 3x minus 1, and that's going to equal the square root of -12. Well, let's see. The negative, remember this here, -1 times 4 times 3. I could break that down at the same time. So here I've got my square root of -1. That part is your I. And then I have the square root of 4, which is 2. So I can write that as 2i. And then what's left is, this is gone, this is gone. I've got the plus or minus the square root of 3. And that's what I get from doing the square root of both sides here. All right, so then I'm going to add 1 to both sides. I can add 1. And how am I going to write that? I'm going to write that by saying, let's see here. Oh, I pulled that out. I pulled that here. It should be out in front here. Let's see. How about if I write this up as 2i times the square root of 3. That's what I meant to do. All right, for the beginning part here. And then I'm adding 1. So I'm going to have 3x equals 1 plus or minus 2i root 3. Okay? And now I got to divide everything by 3. And I could do this too, by the way. I could say this is 1/3 and this is over 1/3. Or I could write it more concisely as 1 plus or minus 2i root 3 and make it all over 3. That would work out as well. Because when you have an I involved, you really can't do any combining here up top. That'll be just your answer written this way. Now, I think in the homework, you have to write it separately. This would be, one would be plus and the other would be minus. So I could say this equals 1 plus 2i root 3, and that's over 3. And then your other answer would be 1 minus 2i root 3 all over 3. So you write them out separately that way, I believe, for the homework. Okie doke. All right, so I'm going to try this one. I'm going to do this over again real quick because of my screw up right here. All right, let me just be right back. Okay, and I'm back. So let's start all over again and take the square root of both sides. All right, I know the left side's going to be 3x minus 1, and then that's going to equal, I've got the I comes out front for the negative, and then I've got this 12 with a square root, and if I did the prime factorization, 4 times 3, and I can say now, what's the square root of 4 times 3? The square root of 4 is 2, so that's going to come out front with the I, and then what's left is the square root of 3. And that's more of the fashion I wanted to write the first time. Okay, so now I can continue to solve this by adding 1 to both sides, and when I add 1, it's going to go out front. So that's going to look like the 3x is by itself, and that's going to equal positive 1, and then plus or minus the 2I root 3. And then from here, I'm going to take the both sides and divide it by 3 to get the x alone. And there's your answer there. So x is going to equal 1 plus or minus 2I root 3, all divided by 3. Okay, and that's your solutions for example number 2. Okay, good. I feel better redoing that problem. Next up is example 3. Now in example 3, I can look at this. If I factor this left side first, okay, because it equals 12, or I could take the 12 and move it over to the left side as well. Let's say, what if I factor this? This is where they want us to go. All right, so I'm going to do this 2 different ways. So if this is given that this is a perfect square trinomial, and that's what they mean by square. What is the title of this? What did I say that was? Completing the square. What are they talking about? What square? They're completing the perfect square. We're creating perfect squares on the left side in our next objective. This is a perfect square here. Perfect square trinomial. Okay, where I take half of the middle term, which is 3, and square it, and it gives me 9. So that's part of the protocol of developing a perfect square trinomial. So right now, if I were to factor this, this would give me x plus 3 times x plus 3. I'll put it over here. X plus 3 times x plus 3. And that'll give me the x squared plus 6x plus 9. And it equals 12. So now if I take the square root of both sides, here's my square root on the left and the square root on the right, I get the left side. Here I'm back to, for every 2 of the same factors, I take out 1. So here I'm going to have x plus 3 on the left side, and that's going to equal, let's see, I've got that 12 again. So what did we say that was? 2 root 3. That's what the 12 will equal on the right side. Now, continuing on, I could say I'm going to subtract 3 from both sides. Subtract 3. And that'll be x equals negative 3. And then in front of the 2 times root 3, I'm going to put my plus or minus sign and put 2 root 3. And that looks good there. And that's my answer for that one. Now, if I were to redo this problem, if I were to redo this problem, I would have x squared plus 6x plus 9 equals 12. And I would notice it's quadratic, so I got to get my equation equal to 0. So that means I'd subtract 12. Let's see what happens. I got to come up with the same answer. So I got x squared plus 6x minus 3 equals 0. Okay, now this is what's going to happen when we, like a preview to completing the square now. And that's what I'm going to do here. I'm going to use completing the square to answer this problem. All right, so how do I do that? Well, if this is my problem thus far, what I want to do is I want to take and leave the two terms in the binomial, the trinomial. So that means I'm going to add 3 to both sides. Let's add 3 to both sides. And then I'm left with x squared plus 6x plus something that equals 3. Now I'm putting that plus something because I'm going to add something to the left side. And I want to make this a perfect square trinomial. Okay, if I make this a perfect square trinomial, I can do what I did up here, taking this perfect square trinomial here. Let me change my colors for emphasis. Here was my perfect square trinomial, and I broke it down into 2 x plus 3's in this example here. Then I could take the square root of that. Because remember, this here, I'm going to write over here, and that could be written as x plus 3 squared. Then I could take the square root of that. Okay, this is all building blocks till we get to another problem, which is here. And this is what I'm doing. I've got a, b, c. I'm adding 3 to both sides for c, bringing it over to the right side. Now I've got to fill in this spot here to make this a perfect square trinomial. And how do I do that? Well, you're going to take the middle term, 6, which is traditionally called b. Take b and divide it by 2, and then we're going to square it. Okay, sounds like a lot to do there, but it's really not bad at all once you get used to it. All right, so I'm going to take b, that's 6, divide it by 2, and then square it. So here you got 6 divided by 2 is 3, and 3 squared is 9. All right, so I'm going to add 9 to both sides. Let me get rid of this now. I'm going to add 9 to both sides, plus 9. So now I'm back to something very familiar where I have this x squared plus 6x plus 9 equals 12. So the right side is back to equaling 12. And then this, I'm going to factor that, and that's going to give me my x plus 3 times x plus 3. And when you're doing that factoring, you could leave it in the factored form and then take the square root this way if you want. You do not have to write it in the x plus 3 squared form. You can if you want. But my point is we're back to the original problem. Let's go up here. So this, we remember, was x plus 3 squared. And up here, we have the x plus 3 squared. And I took the square root of that to give me the x plus 3, which is here. Same problem now. So taking the square root of both sides, left side is going to be x plus 3 equals the right side, which is 2 root 3. And then you can see what I've got. Subtract 3, plus or minus 2 root 3. All right, so we'll have the tools necessary to solve this problem one of two ways. Okay, so here's our objective B, solving quadratic equations by completing the square. All right, and that's our key. So we'll have another way of solving quadratic equations, and in this method, it's completing the square. We're going to create a perfect square trinomial given any kind of quadratic they're giving us, or what we end up with. Okay, here's one we can show it both ways, actually, that how completing the square works. All right, it looks like on this problem, I can factor this in our traditional way. Meaning I can solve for x in our traditional way. So let's see, if I'm doing this, I've got the lead coefficient is 1. You remember all that language there. And I'm looking for two factors. Let me get my sign straight. And I need two factors that multiply to be 5 and add up to be -6. Well, that looks like 5 and 1. That equals 0. So I can see that x would equal 5 and x would equal 1 are my solutions. That's the traditional way. Now, if I take this and do the complete the square with it, I should get the same answers. Okay? So let's see. There's my problem. I'll squeeze it in here to start. Let me change color. And I'm going to have x squared minus 6x plus 5 that equals 0. All right, now I'm going to complete the square to answer this problem. So that means I'm going to subtract 5 from both sides, clear away the c in ABC in our quadratic there. So I'm going to be left with x squared minus 6x plus something that's going to equal -5. Okay, this is the reason why I'm doing this, because I know I've got to complete the square. And all I'm ending up doing is adding a number to both sides, which is perfectly legitimate. So in this case here, I'm going to have, you could use the -6 or just the 6, because this c here, when I'm completing the square, is always positive. So I could take the 6, divide it by 2, and then square it. Here's my little side work that I'm taking. All right, 6 divided by 2 is 3, and 3 squared is 9. I think we just did that. All right, that's what this ends up being. 6 divided by 2 is 3, and 3 squared will equal 9. All right, so I'm going to add 9 to both sides. And now my left side is a perfect square trinomial, so it's going to be x minus 3 times x minus 3. I'm going to write it out this way because you'll probably be doing your factoring this way. Okay, you could rewrite it to be one of these squared, but just leave this as it is. It's two of them. That's what you want. And we also know it's going to equal 4 on the right side. -5 plus 9 is 4. So now at this point here, I can take the square root of both sides. If I take the square root of the left side, then it's going to be x minus 3, and it's going to equal the square root of 4, which is plus or minus 2. So it looks like I'm going to add 3 now at this point, giving me x equals 3 plus or minus 2. So x is going to equal 3 plus 2, which is 5, or x is going to equal 3 minus 2, which is 1. Our same two answers we had for the from the traditional factoring of that problem. But what happens is in a lot of our problems, they're not going to be able to factor it traditionally. We're going to have a number here that will probably ruin it. Okay, but now we have a method for completing the square and taking the square root of both sides. All right, let's try another problem. Okay, so a way of starting off these problems is to look at this and say, oh, this is a trinomial, it's a quadratic, equal to 0. So you could say, I'm going to factor that to begin with. Okay, well, this one here is a problem though, right? You got -2. And then you're looking for two factors of -2 to add up to be 5, which makes 0 sense. So you're not going to do it the traditional way. That's what it's telling you. So now you can say, I'm going to complete the square. If I complete the square, I'll be able to solve this. All right, so what do? Step 1 is to make sure this lead term here is 1, meaning I don't have another number as the coefficient of x squared. All right, so this problem is given to me with the lead coefficient being 1. So that's part of the criteria, and it's already been resolved. So I don't have to worry about that. Next, I want to set this up. I want to add 2 to both sides. I want to clear the c out for now and create the perfect square trinomial on the left side of this equation. So thus far, then, I'm going to have x squared plus 5x plus what equals 2. Okay, now's my time to complete the square. I've got it set up properly. And I'm going to take the 5, divide it by 2, and square it. All right, so that's going to give me 25 over 4. No decimals. Okay, so I want to add 25 over 4 to both sides. So here I got 25 over 4, and this is going to be plus 25 over 4. Okay, I want that in view there anyways. Okay, so this left side now I'm going to need to factor it. All right, so let's see, what am I going to do? So I'll put an x here, both positive signs, so that makes these both positive. And then I need a number here to insert here and here. And they'll be the same number. And that number you're going to find here, inside the parentheses. That's where you can locate it. So that means I'm going to have 5 over 2 and 5 over 2. And now when you check that, 5 halves times 5 halves is 5 times 5 is the 25. And 2 times 2 is the 4. So that'll check out. Okay, and this is where that number is located, because you'll wonder when you have fractions, oh my God, what numbers are we going to put in there? They're right in front of you, right here, inside that parentheses, solved. If that were a 6 over 2, like the last problem, that would be a 3 inside. You can still use 6 over 2, but it's easier to use something that's simplified. All right, so this is what I've got up to this point, and it's going to equal, let's see, I added 25. I've got to add 2 plus 25 over 4 on the right side. Okay, so that's going to be, put it 2 over 1, get my denominators to be the same, so it's going to be 4 over 4. And what about it? 8 plus 25. 8 plus 25. Okay, so this is 4 times 2 is 8 plus 25. That's 33 over 4. Okay, and that's going to give me 33 over 4. Now, let's take the square root. I'm going to give me some space here. And how about if I rewrite this? So far, I've got x plus 5 over 2 squared. I'll square it this time so I don't have to write it again. Equals 33 over 4. Now I'm going to take the square root of both sides. Okay, if I take the square root of the left side here, square root, and I'm going to split these up. I like splitting it up. And I'm going to have now x plus 5 over 2, and that's going to equal the square root of 33 over 2. Finally, one more step, I'm going to subtract 5 halves from both sides. subtract 5 over 2, and subtract 5 over 2. I'm just throwing this over here on the right side. When I do that, I'm going to end up with that x equals, I want to put my value here first. That's going to be in front of the radical signs as a traditional way of writing my answer. I don't want it at the tail end. So it's going to be negative 5 over 2 plus or minus square root of 33 over 2. That's legal to write, or that x equals negative 5 plus or minus square root of 33 all over 2. Here's another way of writing that answer. Okay. Check out your homework assignment and see what they're saying, how you write that answer in. It'll probably be this way up here, I'm guessing. Okay, that was example number 5. Okay, here we go again. So here's my problem. Oh, got my equal to 0, right? So I want to factor this left side. Can I factor this like I know how? I got to try real quick, save me a lot of work. So this, I'm stuck with the 3 in the front, so I got to do the grouping method. So that's going to be 3 times 7 is 21. 2 factors of 21, that give me negative 8. Negative 8. So, 7 and 3, it's the only 2 numbers I can think of. And 21 and 1, that's not going to work. So it's not factorable traditionally. Which means if I'm going to do this, if I'm going to solve this, I've got to use the I've got to use the completing the square method. But now I don't have this as 1x squared to start with. I've got to make it 1x squared. So how do I do that? I have to divide everything, both sides, by 3. So I'm going to divide everything here by 3. And even the 0, even though it remains 0. So when I do this now, I'm going to end up with x squared minus 8 over 3x plus 7 over 3, that equals 0. Okay. Now let's try it. Now we got to deal with these fractions, but the process is still the same. The process is still the same. So let's see if I can handle this. It's in the right form. So I'm going to subtract the 7/3 from both sides. Subtract 7/3. All right, and that's going to give me x squared minus 8 over 3x plus what? That's going to equal negative 7 over 3. This is my problem up to this point here. All right, I have to create a perfect square trinomial here. So that means I'm going to take the 8/3. I'm ignoring the negative because it doesn't matter because this is always positive. I'm going to take the 8/3 and watch how I do this. 8/3. I'm going to divide it by 2. I'll do it this way. Divide it by 2 and square the whole thing. All right, so 8/3 divided by 2 will give me 8 over 6. 8 over 6 simplified would be 4 over 3. Okay, 4/3 squared now, I'm going to square it. That's this square here, where I'm squaring it, is going to give me 16 over 9. All right, 16 over 9. So I'm going to add 16 over 9 to both sides. Plus 16 over 9. Okie doke. All right, so now I've got to write this trinomial. I got to factor that. Okay, so I know it's going to be two of the same binomials. All right, so what are those numbers that go in? So we know it's going to look like this by virtue of this being x squared. That's the easy one. So I'm just going to fill in my whatever I can. Minus, minus. And my numbers that go here and here is going to come from here. Okay, that's when that 8/3 divided by 2 squared. And what remains in the parentheses, it simplifies to be 4/3. Okay, so I'm going to put a 4/3 here and a 4/3 here. And it's going to equal, let's see, I've got to add these two up together here. So when I add these two up, let's see, I got to make my denominators the same. So it's 3/3. 3 times -7 is -21 plus 16 is going to be -5. And that's -5 over 9. -5 over 9. So here, -5 over 9. Now I'm in the position of taking the square root of both sides. I know that's negative, so I'll do it here. Square root of 5, square root of 9, top and bottom. So my left side will be x minus 4/3, and that's going to equal square negative. Wait a minute, I took the square root of -5. Let me clean that up real quick. There, that's a little cleaner looking here where we were working. I got the square root of -5 over the square root of 9. All right, so the square root of the left side is x minus 4/3, and this is going to be the square root of -5. So there's a -1 times 5. Square root of -1 is I. That's going to come out front. And then the square root of 5 just stays the square root of 5. Okay, and that's going to be over square root of 9, which is 3. All right, so now I'm on the doorstep of success by adding 4/3 to both sides. So if I add 4/3, 4/3 plus or minus I root 5 over 3. Okay, so I'm adding 4/3 to both sides. So I've got, was that a plus? Oh yeah, that's the plus. Okay. And so x is going to equal this left side, just as I have it written. 4/3 plus or minus. Notice the plus and minus is in front of the root sign, or anything multiplied there, so it just goes in front of it. And then I have the I root 5 over 3. And that is our solution for example number 6. Okay. Okay, so now in example 7, we're talking find the x-intercepts of the function f of x equals x squared plus 6x plus 7. And when we're finding the x-intercepts, what's the rule? If I'm finding the x-intercepts, I have to let y equal 0. If I'm finding the y-intercepts, I have to let x equal 0. All right, but I'm looking for the x-intercept, so therefore y has to be 0. And remember our discussions from class, which, so long ago now, that f of x was the same as y. F of x equals y. So if y is 0, this f of x is gone, and I'm just going to replace it with a 0. And I could put the 0 over here if I wanted and eliminate it over here, just to rewrite it in a more comfortable fashion. So if we're finding the x-intercepts, we're solving for x now, given this quadratic function. All right, looking at it, doesn't look like I can add 2 factors of 7 to equal 6, since they're both positive here. So I'm going to have to complete the square. I'm going to start by checking my x squared at the beginning, that the coefficient of that x squared is 1, and it is. So I have to divide everything like I did that last problem. Okay, so now I want to subtract 7 to start. I want to create a perfect square trinomial. All right, so that means that C, number in for C, has got to go. So I'm just subtracting it away. So my bottom now is going to be x squared plus 6x plus what equals -7. I'm going to complete the square now by taking b, 6, divide it by 2, and then square it. And again, this is going to give me 9. I mean, what do we have this 3 times already? Okay, so I'm going to have 9 here, add 9, and add 9 to both sides. So I'm going to factor the left side. Now it's a perfect square trinomial, so from doing it so many times, I know it's going to be x plus and plus, and what's my numbers? 3 and 3. And that's going to equal 2 on the right side. -7 plus 9 is 2. How about we take the square root of both sides? And I've got x plus 3 is going to equal plus or minus the square root of 2. And how about we solve for x by subtracting 3? And that 3 is going to go in front of the plus or minus sign. So x is going to equal -3 plus or minus the square root of 2. And that looks like we've got it here. Okay. All right, how about onward to objective C? Okay, here's objective C, and it states for us to use quadratic equations to solve for missing parts of right triangles. Well, right triangles. Here's a right triangle, one version of it anyway. And what do we remember while we have this right triangle here? That, I forgot what I was going to say. Let's see, what about it? These are the legs and that form the right triangle. And a right triangle is here. I mean a right angle. And then this is the hypotenuse, the longest side. Kind of like the key features of that. So we're going to, if I label this A, B, and C, then we're going to have figures like, given the Pythagorean theorem, a squared plus b squared equals c squared. Okay, so we're going to be able to solve for c, and we're going to learn how to solve for either a or b, given this idea of solving the right triangle. All right, let's see what they have in store for us. Okay, let's see if I can explain this some to help us through this. I've got 2 equilateral triangles, and let's start with this first one here, okay? Let's start with this. And there are 2 special triangles. Special in the sense that they are integer angles that we are going to be dealing with, what makes it easier to solve. So if this is an equilateral triangle, then that means each of these angles here are going to be what degree? What degree of angles do these form? Since it's equilateral, they're all going to be 60 degrees. 3 times 60 is 180, and we know that to be true, that the 3 angles in a triangle are 180 degrees. Okay? So, but we're talking about right triangles. So that means this is going to be divided by 2, such as this. Okay, now what happens to, now I've got a right triangle. Okay, and I know this angle here is my 90 degrees. Okay, just draw a line here. Not very straight, but you get the idea. All right, now what happens to this angle up here? It's no longer 60, it's half of that, so it's 30. So this portion here is 30 degrees. Okay, and then on the other side, it's the other 30 degrees to make it 60 degrees. But now my angle here is a special angle of 30, 60, 90. And that's one that they reference, 30, 60, 90 degree triangle on this side here. This is also equilateral here, but now let me think here for a moment. I'm going to have this triangle here, which is going to be, if I cut this in half, then this angle here would be this angle here is where I'm going with this. If I cut this triangle in half, this would be the 90 degree, and then two other angles that make up special triangles are going to be this one being 45 degrees, and this one here also being 45 degrees. Because I've got 90 here, and then 90 here, with 45 plus 45 is 90. 90 and 90 is 180. So this is my other special triangle, and it's 45, 45, 90. And that's what makes it special. Okay, given that, now let's go to our problem here. Go to our problem. It says, let me write it out. All right, here it is. If the shortest side in a 30, 60, 90 triangle is 1 inch, find the lengths of the other two sides. And that's our problem. All right, so we are going here, and I am going to draw, freehand-it if you don't mind. Here's my triangle. All right, and then they're talking about the 30. I know this is 30, this is 60, and this is 90 degrees. Okay, and if the shortest side in a 30, 60, 90 triangle is 1 inch, find the lengths of the other two sides. So here's the shortest side here, from here to here, and that is 1, as stated in the problem. If the shortest side in a 30, 60, 90 triangle is 1 inch, find the other two. Okay, so this is 1 inch, and then the hypotenuse here is going to be 2, and then we've got to find out what this height is in this triangle from here to here. All right, so using the Pythagorean theorem, we can do that. Remember, I've got, I can erase this. This is not even part of it. And I knew something like that would happen. Okay, I hope that's clear enough for us. And just to help us out, I don't really need that. I don't want to clutter things and make things where we can't understand what's going on. All right, so here it is, my right triangle. The shortest side is 1, meaning the original equilateral triangle has to be 2, because the other, if this is equal to this side, then this side over here would be 1, right? Right. Okay, so now I've got to figure out what this side is. Well, this 2 is part of the hypotenuse. So if I know my Pythagorean theorem as a squared plus b squared equals c squared, then I'm going to replace I could call this a, so that would be 1 squared plus b squared equals 2 squared. And I'm going to solve for b squared. So I've got 1 squared is 1 plus b squared equals 2 squared, which is 4. Okay, if I subtract 1 from both sides, then I'm going to have b squared equals 3. Getting b alone, I'm going to square root both sides. So b is going to equal the square root of 3. And there's no plus and minus here because we're talking about lengths of a side of a triangle, and it can't be negative. So it's got to be positive, so b equals the square root of 3. And that's our answer. That's it. Let's try one more on example 9. And what they're talking about is it says table 1 in the introduction to this section gives the vertical rise of the forest double chairlift as 1170 square feet and the length of the chairlift as 5750 feet. To the nearest foot, find the horizontal distance covered by a person riding this lift. Okay, so what are they talking about? They're talking about another right triangle, and they're describing it here as the horizontal distance, and here's the vertical rise, and then this is the length of the lift if you've been skiing before. Many other examples involving a triangle are this way. All right, and so what they're saying is the lift, the one that takes you to the top of the hill, is 5750. And the rise, the vertical rise going up the hill, is 1170. And they want to know what the amount is for this side called the horizontal distance. Okay. So again, taking out your Pythagorean theorem, given this is a right triangle, a squared plus b squared equals c squared, you can just fill in the knowns. What do we know? Okay, well, I know the 5750 is the hypotenuse of this triangle, so that's going to replace the c squared. And I'll write it down here as 5750, and I'll square it. And that's going to be equal to this side here, call this b, is 1170. So that means 1170 is going to go here. And square that. And then I'm going to add the unknown, which is the bottom, which would be maybe b squared or a squared, whatever you want to name the legs. And it doesn't matter for the legs. So this is my problem. And if I take some numbers out, so given our number sentence now that we've got here, let's convert this and answer it. This is basically saying that b squared, so I'll put the numbers to it. So I got b squared plus 1170 squared. What is 1170 squared? And it looks like it's going to be 1,000,000. Let's see, 1,368,900. And that's going to equal 5750 squared, which is 33,062,500. And that's just by squaring these two numbers, so I get these huge numbers here. And I'm solving for b squared. So that means I got to subtract the 1,368,900 from both sides. 1,368,900. Carefully lining up my numbers here, as you can see. So I end up with b squared that equals this right side. And it looks like this right side is going to equal 31 1,693,600. And now to get b by itself, we'll take the square root of both sides, that huge number. So b is going to equal, what is that? The square root of that big number is 5,630 feet. And that's what would be the solution for b. And b meaning this leg here, from here to here. So that is going to be 5,630. And that's our answer. So if you square this number and square this number, it should equal the square root of that number. Or going backwards. Square this number and this number. Square, square, and it'll be the square root of that answer. Subtotal, I guess we'd say. Okay. That is about it for this section. Doable. Practice the completing the square, however. That will take some practice doing. And email me if you have any questions. All right. Thank you.